Okay, good evening. Welcome to
Math number 940.
Math number 940. So I saw a really interesting, or heard about a really interesting project on a podcast that Katie Seckles and Peter Rowlett do called Mathematical Objects, and it involves studying how water cools. So I've had this thing of water. Can you see? Does this show up on the? Can you see that says? What does it say? 70.7.
I think so. Yeah, kind of.
Sorry. Oh, there it is. I don't know why sometimes it's on
Yeah,
70.5. So this is our water that's been sitting out all day. So that's our room temperature, 70.5.
All right.
And we're gonna do two experiments. First, we're gonna take two basically boiling cups of water. We've got water boiling on the stove right now. We're going to study how much they cool in 5 minutes and how much they cool in the next 5 minutes. And then we're going to do a second experiment where we take the same boiling water, pretending like we're making tea with milk in it. And we're going to put, one glass is going to have the boiling water in, and we're going to put the milk in right away. And the second one, we're going to wait 10 minutes and then put the milk in, and we're going to measure the two temperatures and try to understand what's going on.
Okay.
But the mathematical thing we're studying today is a law of cooling that says the change in temperature is proportional to a constant times what? The temperature minus the room temperature, roughly.
All right.
Okay, so what we need to do to measure how much something's going to cool, we let it cool for 5 minutes, and that'll tell us what the change in temperature was, and we'll know the difference at the beginning, and that'll tell us what the constant is, and that'll allow us to make a prediction.
All right.
Another way we could say this, I was a little sloppy. The change in temperature, capital T, is approximately equal to this, or since we're studying calculus this year, there's a differential equation saying the same thing more precisely. The change in temperature over time is proportional to K times T minus T. So this just says the change in temperature over some period of time is going to be constant times the difference in temperature. This is the actual law, the differential equation. That says what?
It just says the change, or the derivative, so the change in temperature is equal to a constant times initial minus this is the initial?
This is the room temperature.
Alright. So initial minus room temperature.
Yeah, not initial, but the temperature at the time. So the
Alright.
differential equation says that continuously this is what's happening. This is just our approximation. Alright, so what we're going to do is we're going to take 2 glasses full of water that's boiling on the stove, and we'll measure their temperatures, and then we'll wait 5 minutes, measure it again, and then try to make a prediction. Okay?